Hello, today I'm going to talk about LeetCode question number 33, search in rotated sorted array. So there is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index, such that the resultant array looks like this. And 0 index. So for example, if we rotate at pivot index 3, so 0, 1, 2, 3, we rotate here. The array basically becomes this. So this guy, all these values shift here, and these 3 in the front shift in the back. So given the array nums after the possible rotation, and an integer target, return the index of the target if it's in nums, or -1 if it's not in nums. And we must write in O of log n runtime complexity. So how do we approach this? So initially we might think, well, why not just check first if the array is rotated, because it says a constraint here is the array is possibly rotated. It doesn't have to be, could be rotated, and we could check that. And then if it is rotated, try to unrotate it and get back the original array. But to check the possible pivot point, or even check if it's rotated, we would need to traverse through the entire array, and this would take O of n. And the question specifically states we need O of log n runtime complexity. So with O of log n runtime complexity, we are basically looking at binary search here. Okay, but how do we do binary search on an array that is pivoted? Well, there are basically a lot of conditions that we have to check. So I'll list them out here. So one condition we have to check is obviously it is the median value of a binary sort, or of our binary search. Is that the target we're looking at? If it is, then we return the index. Easy. So if nums at position I equals target and return. Okay, easy enough. But what if it's not? Then how do we know where to limit our search range? Like here, if we're looking at the target 0, and we're obviously at 7 right now, how do we know in this possibly rotated array to limit our search on this side or to this side? Well, there are a few conditions we have to check. So 2, okay, if nums at the mid pointer, so possibly this could be our mid here. I should have wrote mid up here. So if nums at mid, okay, is greater at nums.right, so we have 2 pointers, left pointer and right pointer, okay, then that obviously means there was a rotation that happened, okay? Okay, so if this condition is true, and so we check for this condition, and okay, if target is greater than nums mid or target less than or equal to nums at the right pointer, okay? So like possibly there could be 8 here, 9 here, 10 here, okay? Then that means, and then obviously if our target is 0, less than 2 here, if our right pointer is here, it's obviously in this range. Then we want to limit our search here, okay? Then limit search to right, okay? And what are the other conditions we have to check? So what if mid is or less than this guy here, okay? If mid is less than the left pointer, okay, and target is less than mid or target greater than left, limit range to left. Okay, so for example here, if we have like 7, 0, 1, 2, 3, okay, and our target is 1, if mid is, target is less than mid, okay. So and this is our midpoint here. So obviously we have, let's say we have an 8 here. So we're searching for 1. So if this is 2, so if this mid is less than this left here, this is our left, and target is less than mid or greater than left, then obviously we need to search in this range. Okay. Okay. So what other cases are there? What if this is in sorted order actually? What if mid is like 7, 8, 9, 10? What if mid is less than right? Okay. And target is greater than mid and less than right. So we limit our search to the right. And 5, and what if, very last condition, what if it's in sorted order? What if you had like 1, 2, 3, you know, in the very beginning of the array? If mid is greater than left and target is greater than left and target less than mid, search in the left range. Okay, so these are the possible things we have to worry about. So these conditions basically check if an array is rotated, and these conditions handle if array not rotated. Okay, so that's what we basically have to do for this question. And yeah, obviously this will take O of n time here. Okay, and yeah, let's get started. Okay, now to code this up, so what I want to do is initialize my left pointer indexes and right pointer indexes. And yeah, those are the only two variables we need. So now we can do the binary search. So while on the left is while the left is less than or equal to right, because obviously a range, we want our left to be at the left and our right to be at the right. Our mid point is going to be the average of those two. Okay. And if, I'm just going to shorten this to mid here. So if at this position mid equals to target, then simply return mid. Okay. And also, just for convenience sake, I want to also check the left and right pointers if they equals to target, just because in a sorted array here, or in a rotated array here, if we're looking for 2 and our left is here and our right is here, I just want to catch that really quickly. These are kind of unnecessary, but I don't have to worry about the logic later of where to limit my search range to the left or to the right. I just can handle it here. I just kind of pre-check here. Okay, easy enough. So now I want to check my first condition here. So if nums mid, okay, greater than nums right, okay, I'm going to check this first condition I outlined in my list back there. So if this mid is greater than this guy, I want to check first if my possible target is in this range. Okay, so like if we had like rest of the array and then 789,012, and if my target is 9, I obviously want to check in this range here. It's the end of the array. Okay, so I want to check if my target is 9, if it's greater than this midpoint. But if my target is 1, I also want to check if it's less than this rightmost point. Okay. And of course, I handle the case if my target is 2. I don't quite really need these statements, but I'd like to check anyway. Okay. So if target is greater than nums at midpoint, or target is less than nums at the right pointer, well, what I want to do is limit my search range left equals mid plus 1, okay, to the right there, or else right is equal to mid minus 1, okay? Else if, okay, if this condition is true, but this else if nums mid is less than nums left, okay? So if you have like the case where it's like beginner array 789,012, and then that's the rest array there, okay? And this is our midpoint. So if this midpoint is less than our leftmost point, we want to check if, similarly to up here, if our number could be possibly in this range here. So if target is greater than nums left, or target is less than nums at this midpoint here, then our limiter should change that to right there, right equals mid minus 1. Else, it's obviously not in this range, so it's obviously not on this over here, so we have to check over limiter range here. Mid plus 1, okay. Else, if they're both false, then obviously this means our array is sorted. Okay, so we can do regular binary search pretty much. If target greater than mid nums mid, then left equals mid plus 1, else right equals mid minus 1. And if after all of this we still don't find our target, it doesn't exist, so we return minus 1. Okay, let me try compiling it here. Okay, looks good. I'll try with the rest of these test cases. Okay, and now I'll submit. Okay, great. Thanks for watching.